we have some elements. Number 1, helium, 2, 4, sodium, and potassium. Let's begin with helium. Helium, He2, But before beginning to draw the electronic configuration, let's conclude what is the atomic number, mass number, number of protons, number of electrons, number of neutrons. Number 1, atomic number. We said before that atomic number written in the lower part of the element. So the atomic number of helium is 2. Number 2, mass number. The mass number written at the upper part, so it's equal 4. Number of protons. We said before that number of protons is the same number of electrons, and all of number of protons and the number of electrons equal the atomic number. Number of protons equal atomic number, so it also equal 2. Then number of electrons also equal 2, because the number of protons equals the number of electrons equal atomic number. Finally, number of neutrons, and we have a rule to calculate the number of neutrons. We said that number of neutrons equal mass number minus atomic number. Mass number equal 4 minus atomic number equal 2, so 2 neutrons. Number of neutrons equal 2. Now let's draw our electronic configuration. First of all, you have to draw the nucleus. We said before that atom consists of nucleus at the center and surrounded by electrons. So this is our atom. This is the atom of helium. And we said before that nucleus atom contain protons and neutrons. So we have 2 protons, and we said that protons have negative, and we said that protons have positive charge, and neutrons with neutral charge or doesn't have a charge. So protons positive, neutrons neutral, doesn't have a charge. So we draw the nucleus of helium atom. Now let's draw the energy levels and both electrons inside it. We have 2 electrons for helium. So we will draw the first energy level, K, and we said before that K is saturated by 2 electrons. So we have just 2 electrons, and we will put them in K level. We have no more electrons, so we don't have to draw more energy level. So this is called the electronic configuration of helium. From this drawing of electronic configuration, we can conclude that if helium element is active or not. Look at the outermost energy level. We have 1 energy level, so K energy level is saturated with the whole number of electrons, 2 electrons, so we can say that helium inactive. It doesn't need to participate in chemical reaction. Let's go to the next example, sodium. (1123). Atomic number equal, we said that atomic number written at the lower part, so atomic number equal 11. Number 2, mass number equal 23, written at the upper part. number of protons, it is the same, atomic number equal 11, number of electrons also equal to the number of protons equal 11, number of neutrons from the law, mass number minus atomic number, mass number equal 23 minus atomic number 11, so the number of neutrons equal 12. Now let's draw the electronic configuration of sodium. First of all, let's draw it with a different color. First of all, draw the atom nucleus, and we'll put protons. We have 11 protons with positive charge, then neutrons, 12 neutrons, and we said neutrons is neutral, doesn't have a charge. This is the nucleus. Then let's draw the energy levels with electrons. We have 11 electrons. First of all, draw K level, and we said that K is saturated by 2 electrons. 2 minus 11 equal 9. We put 2 electrons in K level, so 11, the total number of electrons minus 2 in K equal 9. We have 9 electrons. Then we will draw the next energy level, KL. And we also know that L is saturated by 8 electrons. So 8 minus 9 equal 1. The last electron, 1, will put in the last energy level, KLM. So this is the electronic configuration of sodium 281. Now, the last question, is sodium is active or not? You can think, good, it is an active element because the outermost energy level doesn't contain the whole number of electrons saturated by M. M saturated by 8 electrons, but here in sodium it contains just 1. So sodium have to participate in chemical reaction to lose this electron and become more stable. The last example, potassium. Now let's draw the nucleus, and the nucleus contains protons. We have 19 positive protons and 20 neutral neutrons. Now let's draw the energy levels. The first energy level is K level and contain 2 electrons. The total number of electrons is 19. So 19 minus 2 equal 17. So let's draw the next energy level, KL. L saturated by 8 electrons. So 17 minus 8 equal what? 9. Good. So we have to draw the third energy level, KLM. M is saturated by 8. So 9 minus 8 equal 1. So the last energy level, KLM, N, will contain the last electron. So the electronic configuration of potassium, 2881 in 4 energy levels. So the number of energy levels saturated with electrons in potassium, just 3 energy level, 288 KLM. But the last energy level, not saturated by electrons, it just have 1 electron. It just has 1 electron. So potassium active or not? Active.